In this particular video, we are going to be talking about friction. So when you hear the word friction, friction is a force. And what type of force is friction? Is a force that opposes the motion of a solid object over another. So this simply means that friction opposes motion of a solid object over what? Another. We have the types of friction. Generally, we can classify friction into two. We have the static friction, we have the kinetic friction. So let's talk about the static friction. Static friction, as the name implies, static, when something is not moving. This is the frictional force that acts between the surfaces when they are at rest, that is when they are not moving, with respect to each other. So the friction that acts on the body when the body is not moving is called what? Static friction. An example of a static friction is a table lamp resting on the table. So that's an example of what? Static friction. So from there we also have the number two, which is kinetic friction. So talking about kinetic is coming from the term kinetic energy. Kinetic energy simply means the energy in motion. So that simply means that whenever there is movement, we talk about what? Kinetic. So kinetic friction is the frictional force that acts between the surface of bodies in motion. So when the motion, when two objects are in motion relative to one another, the frictional force that will be acting on them is what? Kinetic frictional force. Then note, static friction can also be referred to as limiting friction. So whenever you hear the word static friction, it's also referred to as what? Limiting friction. While also kinetic friction can also be referred to as dynamic friction. So whenever you hear dynamic friction, it is also referring to as what? Kinetic friction. We have the classification of kinetic friction, we have the sliding friction, and we also have the what? Rolling friction. So talking about the sliding friction, that is a friction of an object when they are sliding against each other. When the objects are sliding against each other, they are referred to as what? Sliding friction. Then talking about the rolling friction, this is the force, this is the frictional force which resists the motion of the body of the motion when they are in rolling. This rolling, when something is rolling, the type of friction when it is rolling is referred to as what? Rolling friction. So that's why we say that it is a force which resists the motion of a ball or a wheel. You know that whenever we kick a ball, the ball rolls. It rolls. Are you there? Also the wheel also rolls. That's another of what? Rolling friction. So wheels of a car, moving vehicle. So that is that. And also guys, we have the fluid friction. So talking about the fluid friction is defined as the friction that exists between the layers of fluid. Guys, if you talk about fluid, it simply means either gas or what? Gas or liquid. That is what we mean by fluid. So the friction that exists in fluid is referred to as what? Fluid friction. And when they are in motion relative to each other. So that is why fluid friction can also be classified under what? Kinetic friction. Under the kinetic friction, because they also involve what? Movement. But this fluid friction exists in what? Fluid. We also have an example of that is the flow of ink in the pen. So friction actually controls the flow of ink in the pen. So we also have the advantages of friction. So what are the advantages of friction? The first one is that friction makes walking possible. Friction makes walking possible. If not for friction, our walking will not be possible. Also, friction enables automobile tires to make a firm grip with the roadway. Also, friction enables a screw or a nail to remain in place after being what? Screwed into position. Also, friction enables the brakes to stop the car and the locomotive to pull the what? Train. These are the advantages of what? Friction. We will also talk about the disadvantages of friction. Everything that has advantage also has disadvantages. Talking about the disadvantages of friction, the first thing is that friction leads to much wear and tear. Friction leads to much wear and tear on the moving part of what? Machine. Also, friction causes heating of engines. Also, much useless work is done by machine to overcome what? Friction. So these are the what? Disadvantages and advantages of friction. Then let's look at methods using friction. How can we reduce friction? So we can reduce friction by the use of lubricants. So lubricants are the most important stuff used in what? Reducing friction. What are the examples of these lubricants? Oil. We have the grease, air, and graphite. So we can also use the bond or roller bearings. We can also use the streamlining of body shapes of what? Moving objects. also we have the loss of solid friction. Talking about the loss of solid friction, the first thing you have to notice is that friction opposes the motion. It opposes motion. The second thing you have to notice is that friction depends on the nature of the forces in contact. Friction depends on the nature of force in contact. What do we mean by this? What we mean now is that talking about friction, it depends on the nature. Talking about the nature, we are actually talking about whether it is rough or what smooth. When the surface is rough, there is high friction. But when the surface is smooth, we can say there is no friction, or we say there is low friction. So friction depends on the nature of the surface in contact, but friction is independent. That it does not depend on the what? On the area. Friction is independent on the area, and also friction is independent on the relative velocity. It is also independent on what? Relative velocity. And also frictional force is proportional to the normal reaction. So this last law gives the formula frictional force is equal to mu r. This mu can equal to F over r, where this mu is called the coefficient of friction, R is called the normal reaction, and this F is the what? Frictional force. Then guys, let's look at the cases of friction. Cases of friction. Now talking about the case of friction, the first case we'll be talking about is horizontal surface. Guys, let's say I have my horizontal surface like this. So the first thing I have to indicate that this horizontal surface is rough. It is rough. So this is very important for me to indicate so that I'm going to know if it is rough, there is friction. If it is smooth, there is no friction, or we say we have low friction. So I can place an object on this surface. So guys, once I place an object on this surface, there are two things you have to note at the back of your hand. The first thing is that weight acts downward. Number two, normal reaction is proportional. Is perpendicular to the surface. So the first thing you have to notice is that the weight of this object is going to act vertically downward. The weight acts vertically downward. And you have to know that the normal reaction will be acting upward, opposite the weight, but acting as perpendicular to the surface. So this is the normal reaction, R. It acts upward. So you have to know something that your normal reaction can be represented as N or R. So that's still the same thing. So your normal reaction acts perpendicularly upward. Then the next thing you have to notice is that, let's imagine that this, you know that before this particular object can move, it requires a forward force. That is, it requires a force to move this object forward before it can move forward. And since the surface is rough, we are going to have our frictional force. And remember that your frictional force is an opposing force, so it acts in opposite direction. Your frictional force is an opposing force, that is a force that will not be allowing a body to move forward. Either it's going to be dragging the body back. So that's what frictional force. So guys, I can make different inferences from this case. The first inference I can make is this: when the object is at rest. Guys, if an object is at rest, is that object moving? No. So since this object is at rest, that simply means that it's not moving. And I'm going to say that the upward force equals downward force, the forward force equals backward force. So I'm going to say that F equals to FR, the forward force equals to backward force. And remember, if FR is equals to mu R, that is from the fifth law of solid friction. That simply means that my F can equal to what? Mu R. This is the first thing. And the second thing is that this upward equals downward. So that also means that my R equals to W. Also remember that if W equals to mg, then my R also equals to what? Mg. So therefore guys, the next thing I can talk about is when the object is moving. When moving. Guys, when the object is moving in horizontal direction, you also have to know that my upward equals to downward. R is still equals to W, and that's equals to what? Mg. When it is still moving. When it is still moving, the vertical, the upward will still equals what? Downward. But the only thing that's going to differ now is this horizontal force, because the object is moving in horizontal direction. So therefore, guys, the idea you have to note is that whenever two forces is acting on a single body, there is going to be a total force that will be acting on that body. That total force can also be referred to as the net force acting on that body. If these two forces, if they are moving in the same direction, the total force on this body is going to be addition of the two forces. But if the two forces are moving in opposite direction, the total force on this body is going to be what? Subtraction. So therefore, since we have assumed that this object is moving, that simply means that it is going to be moving with the forward force, and it is going to have a frictional force like this. So the total force that will be acting on this object is going to be TF, total force, equals this forward force F minus this frictional force. So this forward force F minus what? Frictional force. Because when two forces act on a body, if the two forces are in opposite direction, the total force that will be acting on this body is going to be the subtraction of the two forces. So it is going to be this forward force minus what? Frictional force. Then guys, you have to remember that this my total force TF, I'm going to equate it to what? Mg. But let me say F is equals to Ma. Then my frictional force Fr is equals to what? Mu R. My frictional force Fr is equals to what? Mu R. But I have to remember that my R is equals to W, also equals to Mg. So this is my R also equals to what? Mg. So if R equals to Mg, my Fr will also equals to what? Mu Mg. Do you get that, guys? So this simply means that my total force can be Ma is equals to F minus mu Mg. So therefore, I can make my F the sort of formula, then my F will become Ma plus mu Mg. And my F is equals to Ma plus mu Mg. So guys, before I move on, you have to know that this case 1, which is at rest, that is when R is equals to Mg, F is equals to mu R. This case 2, that's when it is in motion. Then my R is also equals to W, is also equals to Mg, and my F is equals to what? Ma plus mu G. But you now note that this at rest is not only for at rest, but also when moving. At constant speed. So guys, let's talk about the inclined plane. So guys, talking about the inclined plane, the general schematic diagrammatical representation is this. This is my inclined plane where an object is placed on this surface like this. I have my angle theta here. This is my inclined plane, guys. So you have to note something. What you have to note now is that, don't forget what I told you, that the weight acts downward. The weight of the body will always act vertically downward. So the weight will still be acting vertically downward. So the next thing you have to note now, guys, is that once the weight is acting downward, the normal reaction is always perpendicular to the surface. So the normal reaction is going to be perpendicular in this manner. This normal reaction perpendicular to the surface. Then what you have to note is that my normal reaction must equal to the weight. But with what I've drawn here, my normal reaction is not equal to the weight. So what am I going to do? What I'm going to do is that I'm going to resolve weight. I'm going to resolve this weight into the perpendicular direction. As W cos theta. Also resolve the weights into the parallel direction as W sin theta. So I'm going to be resolving this weight into the perpendicular direction and also into the parallel direction. So resolving the weight into the perpendicular direction give me W cos theta But parallel direction give you what? W sine theta. So resolving this weight into the perpendicular direction is going to be written as this. W cos theta. So this is the perpendicular component of the weight. But the horizontal component of this weight is going to be placed here. So this is be the what? This W sine theta is going to be the horizontal component of this weight. Then you have to note that whenever we place an object on an inclined plane, the object will automatically move down. It what? Automatically moves down. So you have to note that the force moving the object down the plane is the parallel. Force moving the object down the plane is the parallel component of the weight, which is actually W sine theta. So if they ask you to calculate the force that is going to move the object down the plane, the force F will just equal to what? W sine theta. So the force that moves an object down the plane is what? W sine theta. And you have to know that the angle theta is called the angle of friction, or the angle of what? Repose. Angle of friction equals to the angle of repose. Then you have to know that for an inclined plane, if they ask you to calculate the coefficient of friction, your mu is equals to what? Tan theta. So let's look at some example to round up the friction class. So you have to know that the first example we have here is that if an object just begins to slide on a surface inclined at 30 degrees to the horizontal, the coefficient of friction is that. You will just write solution. Whenever you are looking for the coefficient of friction and you are given an angle theta, you will just use this formula. Your mu is equals to tan theta, that's equals to tan 30, and that's equals to what? 1 over root 3. How we say what? Or the answer is what? Root 3 over 3. Okay, the next example we'll be talking about now is that a force of 20 Newton is applied parallel to the surface of a horizontal table. It's just sufficient to make a block of mass 4 kg move on the table. Now listen to this. They say it's just sufficient. It's just sufficient. That means that the body is not moving yet. It is about to move. That simply means the body is at rest. The body is static. So the type of friction we are going to be talking about here is going to be what? Static friction or limiting friction. Because another term for static friction is what? Limiting friction. So it's just sufficient. It's not moving yet, it is about to move. It's just sufficient to make a block of mass 4 kg move on the table. So therefore, guys, I'm going to do this resolution. I'm going to use this case of friction in which I have an object placed on the table like this. The weight acts vertically downward. The normal reaction acts upward. I have my forward force F, where's the frictional force F. Since it is at rest, that simply means that your R will equals to W, up equals down, and equals to mg. And your F will equals to FR, and that is equals to what? Mu R. That's it. So since I'm looking for the coefficient of friction, I'll just say that if F is equals to mu R, that simply means my mu is equals to what? F over R. And also, if R is equals to mg, you know that my R is equals to W is equals to mg, so R is equals to mg. That means my mu is equals to what? F over mg. Go to the question, you will see that they say that a force of 20 Newton, this simply means the force is 20 and the mass is for 4 kg. So that will just be 20 over 4 times 10. And this equals what? 0.5. So the point of view is what? 0.5. This tutorial is that a force of 10 Newton drags. The term being used is very compulsory. Drags. When they drag something, that simply means the thing is already in motion. A mass 10 kg. So I've just write solution. On a horizontal table, this is the horizontal table. This is the mass. This is the mass. The weight acts vertically downward. Your arm acts upward. Since it is being dragged forward by a force, the forward force F is equal to 10 Newton. So since they say that on the table with an acceleration of 0.2 meter per second, my A, acceleration A, is 0.2 meter per second square. They say that the coil of friction between the moving mass, No, so that therefore, guys, know that the frictional force acts in opposite direction like this, F1. Then you have to understand something that since they say it is being dragged, right there, it is being what? Dragged. That simply means there is motion. And remember something that before this forward force can move this object forward, this force 10 Newton must be greater than this frictional force. So that simply means that the first thing is that it is moving in the other direction. My vertical direction R will equals to W. The first case, number one, R will equals to W, and the W is equals to what? Mg. But number two, before this object can move forward, this forward force F must be greater than this frictional force. So this is my F must be greater than what? Fr. Before the forward force will move, we drag this object forward, it must be greater than the frictional force. So my F will equals what? Fr. This F is the forward force, which is 10 Newton. And my Fr is what? Frictional force. And remember that whenever a body is moving, or whenever a body is being acted upon by two forces, they are going to add what we refer to as what? Net force. The net force is going to be the total force acting on that object. So the total force that will be acting on this object will just be the subtraction of these two forces. So my total force, Ft, is going to be F minus what? Fr. That's it. Then you have to know that my Ft is equals to Ma, and my Fr is equals to what? Mu R. So my Ft, so this expression is going to turn to Ma is equals to F minus what? Mu R. Mu R. Remember that my Fr is equals to mu R, so my Fr is equals to mu R, so that is M is equals to F minus Fr. So we are going to make our mu the formula. So bring this minus mu R to the other side, bring this Fr to the other side. So this simply means if we change this to mu R is equals to F minus Ma. This Ma goes to the other side, this minus mu R comes in. Then my mu equals to F minus Ma over R. I know that my R is equals to what? Is equals to Mg. I will just substitute it. So my mu is equals to F minus Ma over R, F minus Ma over Mg. So remember that my F in the question is 10 Newton, so that is 10. My M in the question, that is 10 also, 10 kg. And my A acceleration is 0.2. All over my M is 10, and my acceleration due to that also what? 10. So if I substitute this, I'm going to get my mu to be equals to what? 0.08. Thank you for watching, guys.